Here's a problem from 1989 under the category complex numbers. Find the value of that long expression in a plus bi form. This problem requires decent knowledge of complex numbers, so if you are not familiar with complex numbers, you should check out my video about the basics of complex numbers. So first we need to simplify the numerator, and because of how exponents work, we can add up all the numbers that I is raised to, and then we can just figure out what that is. And that's the average of the first and last terms times the number of terms, which turns out to be 22. And that's 715. So this is I raised to the power 715. And that's equal to I raised to the power 4 raised to the power 178 times I raised to the power 3. And that's, since I raised to the power 4 is just 1, that's just I raised to the power 3, and that's negative I. So the numerator simplifies to something pretty nice. Now let's look at the denominator. This is a little bit harder because we're adding, so you can't just group the exponents onto one I. So let's just write it ourselves. So let's look at those four first. The first one is just I, and then you get 1 and negative I, and negative 1. So the sum of these first four terms turns out to be 0 because the I and the negative I cancel out, and the 1 and the negative 1 cancel out. Now let's look at the next set of terms. And this turns out also to be I plus 1 plus negative I plus negative 1. And this is because of all the numbers in this sequence are just multiplied by I raised to the power 12, and that's equal to 1. It just, each of those corresponds to each of the ones in the first one. And obviously this is also equal to 0. So how many groups of these are there in this big chain? And the last group that we see is I raised to the power 49 plus I raised to the power 52 plus I raised to the power 55 plus I raised to the power 58. And this, again, sums to 0 because you multiply each term by I raised to the power 48, which is also equal to 1. So you get all of that, and then the last two terms are still I raised to the power 61 and I raised to the power 64. So we basically rewrote we rewrote this thing, and we found the groups of numbers that add up to 0. And these last two numbers here are equal to I and 1. So the denominator just adds up to I plus 1. So now when you write the numerator over the denominator, we get negative I over I plus 1. And we simplify this by multiplying the numerator and the denominator by 1 minus I. And that's the complex conjugate of I plus 1. And that gives us negative 1 minus I over 2. But the problem asks for A plus BI form. So we just write it as negative 1/2 minus 1/2 I. And that's our answer. So to do a problem like this, you isolate the numerator and denominator and then simplify them separately. And if you need to, you use complex conjugates to get rid of a complex number on the denominator so we can get it in A plus BI form.